Like, I just finished paying off my loans not too long ago. What do you want from me? Okay. Create a 97% confidence interval for the true percentage of Afghans who don't have trust in their elections. You guys kind of with me? We'll do this one together, and then I got a little handout. It's a little bit different for you to try on your own. So what can I get from what I told you? Again, it almost doesn't feel like I gave you enough to go on.
Divide 493 divided by 6.
I love it. And what would that give you?
The probability of them don't trust.
Be less verbose. Tell me the symbol for what that would give me. P hat. I love it. So P hat would be
Probability of
493 out of...
738.
Now here I will be very specific. You want to take these percentages out at least 3 non-zero decimal places, just like standard deviation. If you round more than that, it's going to throw your results off by quite a bit. Go off to 3 places is pretty good.
0.668.
668?
Yep.
Not too bad, right? So some problems in the homework will give you this many out of this many. You got to calculate your own percentage. Some of them will say, we see that 24% of them, so they gave you P hat directly, right?
Like you said, like go like 3 non-zero. If it was 0.0608, we need to have to go 4 decimal places since it's a 0.
I mean, pass like 0.0000000, and then wherever the number starts, go 3 from there.
Yeah.
Yeah, so if there's a 0 in the middle, it's okay. It shouldn't be that small normally, so we'll see if that continues to make sense. What's Q hat?
Negative point. 738 minus 90.
Yeah, 0.332. Everybody see where I got that from? P and Q always have to add up to be 1, because they're opposites of each other, right? Successes, failures.
Yep.
So if P hat's 0.668, Q must be 1 minus that. Cool. And the shortcut, I don't know if I ever told you this. 1 minus any decimal, make them 9. 3 makes that 9. 3 makes that 9. Make the last one 10. Or, you just got there. Let that do the work. And believe it or not, I've got almost everything I need except for Z-score, right? What's the Z-score going to be for a 97% confidence interval? How much is out here?
0.1.
Good.
0.0.
Half of 3%, 0.015. You guys, there's 3% outside, so there's 1.5% on one side. Get 1.5%. I like 2.17.
6, 7.
All right, 1.015 is exactly there. 2.17.
Yep.
So my confidence interval now, I just got to throw it into the formula. The formula is percentage I see from my sample, give or take this many standard deviations. So I get P hat was 668, give or take Z we just looked up. P hat is 668, Q hat is 332. Oh yeah, it's up here. And N was
738.
738. Good, be careful. It's got to be the bigger number. Now it's really easy to put this in your calculator incorrectly. In fact, I've written it with way too many parentheses, so if I really want to be careful, and actually it depends on which, if you have a newer calculator, it's better. You don't want to close a parenthesis until you're done. Now, if you have the newer calculator that actually builds the square root over, you're golden. If you have the older calculator that has a parenthesis open, you don't want to close it until you get all this stuff in there. The minute you close it, you've cut your square root off. Sounds painful, but... So let's see. So if I look at the error, it would be 2.17 times the square root. 0.668 times 0.332 divided by 738. So there's my error. And did somebody remember? I tried to get the numbers close. I didn't really expect to get this good. I don't know if you guys remember what the... Come on, you can do it. Remember here? Plus or minus 3.8 percentage points? Right? What did we just get? Basically freaking 3.8 percentage points. You guys with me? We effectively, we didn't use the exact same numbers. They didn't give us hard numbers. But I tried to make it come out at least close. And we pretty much exactly got what they did. Give or take 3.8%. Okay, maybe. So it's to be 0.668, give or take 0.0376. And now you just got to add it, subtract it. Is that cool? It's in there. Oh, you can't see it on the screen there, but it's, yeah. It went off the screen. That won't even show it to me. Okay, now it's destroyed it. Okay. Now it's free. It won't show it to me. There it is, see? Alright. Yay. It's way at the end. You can't see it. Yeah.
Is it okay if we rounded that to 0.038? Or did you...
Yeah, that's fine. I'm not going to be too concerned unless you start rounding it too much. Yeah. So at least the same number, if not one more decimal place than what you're using the first part. So what do you guys get real quick? Anybody do that? From
0.78.
0.706.
706 up here.
0.630.
630, yeah, roughly. Okay.
6304.
I got you. I'm with you. So from 63% up to 71% almost. And there's only a 3% chance that it's not in there. All right, so that's pretty good probability you're wrong. But I can live with that. Okay. Maybe. So it's not too bad, right? The math isn't too weird. The concept is not as bad as it first sounds, I'm hoping. If you fish, that might help you understand some of my analogies. I don't even fish, so I still somehow understand. Okay. Yes, sir.
So then how exactly would we write this one?
So this one we'd say, let me not forget what I got here. We are, help me out. We are 97% confident that
The
interval
63%.
Yeah, you're going to say 63% to 70.6%
70.6%.
contains
The confidence.
the true
Trust of. No trust of.
the true what? You always want to reference the careful. This is not a mean problem. This is a percentage problem. So the true. So it's going to be one of those two parameters. It's going to be the mean we're trying to catch, or the true percentage we're trying to catch. So it contains the true percentage of Afghans that
with no trust
have no trust in elections. Can't blame them too much for that. Is it cool? Not too bad, right? Not horrible. It's my hope. Okay. That's plenty for today. So next time we're going to talk about one thing about, can anybody tell me, I got you all excited and then I'm going to ask a question. You're all like, you can go. No. One thing about the stuff we did in 7.3 doesn't really ring true. Oh yeah, I did have we'll do this next time. Actually, wait. You guys do this at home for next time. One thing we did for 7.3 doesn't really ring true. What definitely rings true is we don't know the mu, but we can get the x bar. But if we don't know the mu, what else do we probably not know? What two things do we normally get from a sample or a population? Two numbers we normally get. We get the mean. So we don't know mu, we probably don't know sigma either. How could we know the standard deviation for everybody if we never talk to everybody? So 7.4 talks about what to do when you only have S, not sigma. When you only have a sample standard deviation, you got to adjust something. You're not as certain anymore about your stuff. Okay, so this I want you guys to work on at home and bring it with you next time. Yay. Extra credit, oh, yeah. I don't even think it's on there today, so I need to add some. I need to add some so you guys can do it for extra credit. Okay. Yeah.
Is going to be on the next test?
As a bonus question, it could be. Since it's extra credit, I could really only make it a bonus question.
Oh.
Yeah.
Have you corrected like all the homework already or no?
No.
Because I remember I just did the first packet that was.
Okay. So I did have you up through 2.4, up through 2.3, but I didn't have after that, so let me make a little note. So you think you have up through how much?
Because I did the first packet that you were collecting. I don't remember what was the
Oh, for the
homework.
first
Yeah,
test.
for the first test, I did all that.
Yeah, the first test
The second
homework
test, I'm
was
still working
through
on it. 3 point something, right?
3.3.
3.3, that's what I finished. I didn't do the other packet.
Okay.
I'm working on it.
I'll look for it.
Alright.
Actually, I forgot I had some, it's probably back in my office. I had some homework that had no name on it.
Alright, you think
So
it could be
it
mine?
might be that. So I'll take a look and I'll bring those next time. You can tell
Alright,
me.
thank you.
Okay.